Again, welcome back to Unit 7, Part 4 lectures. In these lectures, we are going to cover the hypothesis testing for proportions. So our main objective is to use the z-test to test the population proportion P. Again, in our previous lectures, we learned how to use the z-test to test the population mean, and also how to use the t-test to test the population mean. So in these lectures, we are going to use the z-test to test the population proportion. So here we say a z-test for a population proportion is a stat test that we use to test population proportion. And also it can be used only when the binomial distribution is given such that NP is greater than or equal to 5, and also the NQ is greater than or equal to 5. N is the sample size, P is the probability of success, Q is the probability of failure. The next, the test statistics is the sample proportion. So the sample proportion again represents the P-hat, and that will be our test statistics. Then the standard test statistics is Z, which is P-hat minus P divided by square root of PQ divided by N. So we should follow the steps here now in words and also in symbols. So first thing we need to do when we are using z-test for portion P, we have to verify the NP and NQ. We make sure NP and NQ are greater than or equal to 5. Then next we state our claim mathematically and verbally, identify the null and also the alternative hypothesis. So we state our HO and HA. Then next, we have to specify the level of significance, which is the alpha always given to us. Then next, we sketch the sampling distribution. Then we determine any critical value using the table 5. Again, table 5 is the standard normal table in our course textbook. So if you are using different course textbook, the standard normal table can be any table number and also any appendix. Then next, we determine any rejection regions. Then we find the standard test statistics. Now, rejection region, or what we have to decision based on the critical value and also the alpha value. So we find the standard test statistics. From there, we can be able to find again critical value, etc. So here we make a decision to reject or fail to reject the null hypothesis. Now, if Z is in the rejection region, then we reject HO. If it's not, then we are not going to reject H. Then we need to interpret our decisions in the context of the original claim. So we can see that the steps are the same as our previous Z-test and T-test for the population mean. Now let's see an example here. Here they say Zogby International claims that 45% of people in the United States support making cigarettes illegal within the next 5 to 10 years. You decided to test this claim and also ask a random sample of 200 people in the United States whether they support making cigarettes illegal within the next 5 to 10 years. Of the 200 people, 49% support this law, and at alpha equal to 0.05, is there enough evidence to reject this claim? So here, because we have 49%, this would be like a proportion. 49% support this law. We need to test the proportion. So first, we need to verify NP and NQ if they are greater than or equal to 5. So we check 200 times 0.45 and also 200 times 0.55. If we know the P is 0.45, then the Q will be 1 minus 0.45, which will give us 0.55. Then next, we need to state our HO and HA. And here is again, it's proportion. Because as we said, we can see from the question here, 45% and also 49%. So these are percentage proportion values. So we say that the claim said 0.45, 45%. So if it's P equal to 0.45, then we say P not equal to 0.45 is the alternative hypothesis. Alpha is given to us to be 0.05. So next we are going to draw the rejection region. And here we have our, again, this is two-way because not equal. So we have negative 1.96, positive 1.96. This is Z value. Anytime we are looking for Z value and alpha is 0.05, the Z value is always 1.96. So now we know our rejection region. So now we move to the next step. We calculate the test statistics, which is P hat minus P divided by square root of PQ divided by N. And the value gives us 1.14. So now we can make our decision. We know the value of the critical value, and also we know, here we say fail to reject H. Why? Because we can see our value here 1.14, and we have negative 1.96 to positive 1.96 to the right, to the left. So 1.14 will be in the rejection region, which is the brown area. I mean, it will be in the accepted region, which will be the brown area. So here we say fail to reject H. We fail to reject H. Actually, that's 1.14 is in the brown area. So here we say at 5% level of significance, there is not enough evidence to reject the claim that 45% of the people in the US support making cigarettes illegal within the next 5 to 10 years. So again, either reject or accept depends on two values. Depends on the critical value and also the test statistic. And we can see from here it's two-way. So 0.05 z-test means we get negative 1.96 and positive 1.96 for the critical value from the table. Then we find the test statistics. It falls within the brown area, which is again accepted, or I would say fail to reject H area. Now we have a second example. Here we said a Pew Research Center claimed that 55% of US adults, so this would be a proportion again because we are talking about percentage of people. So 55% of US adults regularly watch their local television news. You decided to test this claim and ask a random sample of 425 adults in the United States whether they regularly watch their local television news. Now, of these 425 adults, 255 responded yes. Now, our question is, at alpha equal to 0.05, is there any enough evidence to support the claim? So the same thing first, we need to verify NP and NQ that they are greater than or equal to 5. Then next we find the NP 234, the NQ 191. Then we state our HO and HA. Remember, they said greater than and less than or equal to 0.55%. So HO is P is less than or equal to 0.55, which means HO will be greater than 0.55. We have our alpha to be 0.05. So we can find the Z. And then here again, we say greater. So it's only one way or one tail. If HA is greater, that means we go to the right side, it's greater. So again, we find the Z value here 1.645. Then we need to find the test statistics using the formula P hat minus P over square root of PQ divided by N. We plug in the value, we find it to be 2.07. After that, we have the test statistics value, we have the critical value, so we can make our decision. Now here they say we should reject HO. Let's see if it's right. Yes, it fell in the blue area. Again, the brown area, we accept HO. The blue area, we reject HO. So finally, we will say that at 5% level of significance, there is enough evidence to support the claim that more than 55% of US adults regularly watch their local television news. Now, HO said is less than or equal to 0.55. So HA is greater than 0.55. So we say more than 55% of US adults regularly watch their local television. So this will be the summary of our lectures. Again, these lectures, we use the Z-test to test population proportion here. Again, thank you and see you in the next lectures.